Okay, so today we're going to implement this RAG approach, contextual retrieval, which is an anthropic research. And how it works is you prepend a special context for each chunk based on the entire document for RAG purposes. Essentially, how it works is you grab an entire article, like the analytical engine Wikipedia, which just for test. So we grab this entire article and we pasted it in ChatGPT. This is just for test. We're gonna make this programmatic, but we say here is the full document, and we pasted it. And then next up, we are following the Anthropic's research paper on this, which I found in the tweet. Here they put in the whole document and the chunk. Because we're gonna do this for each chunk for RAG, and then we print we also grab this. Please give a short, succinct context to situate this chunk within the overall document for the purpose of improving search retrieval of the chunk. Answer only with the succinct context and nothing else. Let's grab that. And then here also I forgot to mention that we grabbed a piece of it. This paragraph, we're assuming this is going to be our chunk in our retrieval, one of the chunks. So we're going to do this for each paragraph programmatically, but for the purpose of demonstration, we just grabbed this part. We pasted it. Here is the chunk we want to situate within the whole document after the full document. Plus, we write this, and then we just run it. Here it explains, this chunk describes the memory and arithmetic capabilities of Charles Babbage analytical engine and its storage capacity, all that. It explains it
Right.
in conjunction with the analytical engine. If you look at the chunk, see, it doesn't mention anything about analytical engine. See that?
Yeah.
But here it put it in context. It said, okay, it's about the memory and arithmetic capabilities of Charles Babbage's analytical engine. So apparently this is important. So then you grab this. Essentially what you do is before you embed the document, let's say chunk.txt, you prepend this description before your chunk. That's it. So this was our chunk. Something like that. Once you do this, then the performance improves up to like 67% because this chunk is now not only has the details, but it has the overall context of what this document was about and what this particular thing within the document describes related to the full document. Isn't that amazing?
Yeah, that would be good.
Okay, I wonder how, I'm just looking here to see how they, maybe we can read this a little more after we, methodology, further boosting performance with reranking.
Yeah.
What does it say? Further, in the final step, we can combine contextual retrieval with another technique. Okay, you know what? We'll come back to this.
Yeah.
Perform initial retrieval, get the top potential chunks. Pass the top entry, so you get quite a lot here, 150, because you're gonna re-rank it. Pass the top n chunks along with the user query through the re-ranking model. Re-ranking is a commonly used filtering technique. Using a re-ranking model, give each chunk a score based on its relevance and importance. So I guess there's specialized models for this. Perhaps Gina actually has a re-ranker. That Gina, remember I sent you that Gina URL?
Yeah.
It has, see, re-ranker. It has a lot of stuff. Maximize search relevance rank with cutting edge re-ranker. And it gives you a 1 million, like you get an API key right away. You can use this, your API key. So this is a re-ranker. What is a re-ranker? It takes a bunch of chunks and it ranks them based on which chunks would be the most best ones to be able to answer a question, pretty much. So we perform two additional steps to RAG. One is to add context in the beginning of each chunk, plus apply a reranker. Well, it's optional. This has nothing to do with this approach. I mean, this is just additional, right? On top of the cream on top. So let's begin. So we're gonna, okay, well, first we need a document, txt. And this document is going to be this article. Just gonna copy this. Let's grab that, put it here. Okay. So now we need to first chunk these. Let's create, let's do it one by one. Let's do chunk.py, chunker.py. Okay. Let's say, let's use command. I like to start with Control K, but let's do, because now the composer in the latest update of cursor 0.41 can actually snap into the chat. I'll show you how. So you bring up the composer, small window with Control or Command I. See, it is just snapped right here.
Right.
And then I can do Control I again, I believe, to unsnap it. Or I could have done Control I. Oh, okay. It just shows up right here immediately. It doesn't even show up otherwise. But if you do Control Shift I, it still brings up the control panel. Anyway, so now we have our composer. We can say use tick token to split the et. We're going to refer to this file, document.txt, into up to 1,000 token chunks. Or where paragraph breaks are. Use GPT for encoding. Let's see what it does. I mean, Composer is going to cost you twice for a single file, because when Composer working is one usage, plus applying is one usage. So Control K probably is a better option here. But just to show you this new Composer feature, then we'll switch to chat and okay. Model GPT-4. I'm not sure if this is gonna. I think there is something called UCLK1000 encoding. There's this encoding. I just happen to know the name. Yeah, CL100K base. This should work. This is just technical. I think GPT-4 would have worked possibly. Anyway, so this is gonna look for paragraphs. Otherwise, it's gonna go up to text max tokens. Current chunk tokens. Yeah, it's going to look for paragraphs. If not, it's going to keep adding to, okay. But let's do Control L instead, just regular chat, and save the chunks to, save the chunks. Okay, let's also, so normally in RAG, you also want to have overlap, like the first chunk's last bit overlaps with the beginning of the next chunk's bit a little bit. I'm not sure if you need to do that here, though, since it's context. Let's do it anyway. Let's also have 200 tokens overlap between chunks. Yeah, but this is not chunk overlap. Overlap. We don't have any. It didn't implement it. Please implement this code. Oh, length chain. Oh, it wants to use length chain. Don't use length chain. That's why. Just want to do it like
Hmm.
encoding for a model, and it wants to use CL100K encoding. All right, let's apply. It's kind of slow. Okay, you know what? It's being slow. Let's do it with Control K. Let's have 200 token overlap. And let's save the chunks into JSON with indent. Okay. See, each one kind of works. You got to know which one. Okay.
Yeah.
I'm sure this will work. Let's run chunks. So here we go. We have our chunks. One second.
Ha, özür dilerim. Bugün gidecek misin onu
Gideceğim.
soracağım. Bugün gideceğim.
Sorry about that. Okay, so here's our chunks. One way we can actually see if overlap happened. Look, I can select this. See how it's lighting up here?
Yeah.
So that's the overlap. Let's look here. See, this is the overlap. So we have a little bit of overlap. Okay, we figured that out. So now we have our chunks. Now we need to get context. Right. Let's do context for each chunk of pi. Let's do it like this. One chunker to context for each chunk. So we can keep track of them. I'll actually make a separate video on this, hopefully, but let's figure this out first. So here we're going to use plot, but with the caching. Plot caching docs, prompt caching with Claude. Get started, documentation, Python. Yeah. So system message. This is the entire system message. Can insert. Okay, let's grab this sample code, bring it here. So you can use Haiku, I suppose, but Sonnet, I'm not sure if caching is available with all models. We'll just use Sonnet anyway. They say with caching, it's 10 times cheaper or something like that. As a matter of fact, let's double check that. See, yeah, we can use it with Haiku as well, but Sonnet normally input tokens costs you $3 per million. But when you write it to cache, the initial write costs you just a little bit extra, but then after that, it's 10% of the cost.
Right.
And the context lasts for 5 minutes. But since we're gonna use it all at once anyway. Please feel free to ask any questions if you have any. Prompt caching is easy. Apparently, all you have to do is cache control type ephemeral. So here we are going to say you're an AI assistant tasked with writing context, short context for document chunks based on the content of the entire document. Okay. And here we're going to, this needs to be an F string. Okay, open. I'm going to select all of this, Control K, open, read I'm going to say read document.txt. I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects. As a patron, you will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well. Oh man, he wants to change the whole code. Only. Read document.txt only. Cursor is acting weird. Okay, here we'll do read. So instead of selecting the entire thing, I'm just going to go into a single line and say read document.txt. Oh man, it just, see, it knows, it's keeping some kind of memory or something. It wants to do a bunch of stuff I don't want it to do. I just wanted it to open. See all that?
Yeah.
That's interesting. This is not very good. I don't know what they changed, but it wants to do more stuff than I wanted. Okay, let's do read content. Okay, read document.txt and pass it to system message. Let's see. I guess, yeah. Okay, it did it. Maybe it wants to be more helpful. Maybe my mind is still back in the olden days. Okay, anyway. Here, but we need an F string. It says, here is the document content. Let's again take a look at Anthropic, see how they did it. They just passed it like this. Let's do it exactly as they did it. Let's do a triple string. Document like that. So we're going to read it and I pass it. Then, and this cache control is going to automatically cache it for us. In the user message, here's the chunk we want to situate within the whole document. Grab that. And let's do Control L, add this to user message. Chunks. Let's see what it does. Because we want the chunk to be in the user message. Because we can't cache the chunk. Apply. Okay, good. This time it worked, but it wants to do this, provide a brief summary. Delete that. Here's the chunk we want to situate within the whole content. Please give a short succinct. Okay. Answer only with succinct context and nothing else. But we need to retrieve the chunk content. Let's again Control L this or Control L. Read the first chunk from chunks.json. Apply. close. Oh, we have to accept it. Accept. Okay, so it's going to read the first chunk. Let's run this with F5, so make sure it's reading it. Debug. First chunk. Wow, we got an error. Chunk 0. Let's try this again. Yeah, chunks is chunks is not a list. Oh, it should be a list when it reads it. Yeah, chunks. I don't know why this is happening. It shouldn't. You know what? Here, let's do this. Return chunks. Let's return all of the chunks. List. Oh, we need to convert it to a list. Okay, this should work, I guess. All right, let's run this. Yeah. It's given the whole object. Man, I wish print response dot content 0 dot text. Yeah, here. This chunk provides the overall overview of Charles Babbage. We can take a look at the third one. This chunk discusses the influence and legacy of Babbage's analytical engine. So now for each chunk, we're going to grab the chunk, add it to the beginning of the chunk, and then save it again, right? Let's do this with async. So I don't know if we should use async. I wonder, because I'm curious, if you use async, if cache control is going to kick in. You know what I mean? Because the API needs to receive this first message to make sure that this part is being chunked. Sorry, cached. This entire document, right?
Right.
If you call it with async, then you're making all the calls at once. What if it doesn't know, I guess is my point. See what I mean? What if because you're making all the calls at once, that part, I'm not sure. I think it should work, but I don't know a good way to test it either. Right now, off the top of my head, we can just do it sequentially, but this would take a minute for long documents. All right. So let's say get context for each chunk, then append it to each chunk with a paragraph break between the context and the chunk, and then save them to chunks with context.json. Read the chunks. It's going to go loop over the chunks, apply, accept. I think this is it. Let's do it. Let me double check Anthropic's documentation. So you should know now that it's chunked. sorry, cached. All right, let's run it. Let's have a print statement. If print f chunk getting context for chunk ID. Anyway, it already did it, so it didn't took too long. Yeah, see, it's going to add these with a paragraph break. This chunk introduces. This chunk discusses early adaptation. This chunk discusses instruction set, each with a paragraph break.
Right.
So we did it, essentially. So now we have our chunks with context. Now, third one is to use this embed and use .pub. So we can do this multiple, I guess this part is kind of up for grab. We can use OpenAI and Embedding and then use cosine similarity search. We can also use like ChromaDB. I guess we should just do it from scratch with OpenAI. Yeah.
Yeah.
But then when we do that, we're gonna have to save it to like a JSON file or something. Versus ChromaDB automatically makes it a vector DB. Maybe we'll, if we have time, we'll do that other one too. So let's do. Okay. So I wonder at this time maybe Composer might come in handy. So let's give it all the files. We have a chunker, context. Let's see how it goes. Embed and use and chunks with context. Let's say use OpenAI embeddings. It's gonna make a mistake, but in the API call, we'll fix it. OpenAI embeddings to embed each chunk. Save the vector DB in a JSON file, let's say. This script part should also allow us to query the embeddings with top and chunks using cosine similarity. It's going to write the function for that, the mathematical formula, the linear algebra for it.
Okay.
Cosine similarity. If the document has been embedded already, then skip the embedding. The script skips the embedding part. Okay, we can give better instructions, but I'm curious if it's going to understand all this. Okay, let's see here. So it didn't confuse. I was wondering if it's gonna get the chunker and all the other stuff, bring it into single file, which we didn't want actually. We can ask it to do that, but it didn't. So it's just gonna open chunk with context. It's gonna get the embeddings. It's gonna dump it to a JSON file, embeddings file. Here though, it's gonna return the embedding. It seems it's gonna only save the embeddings. I'm not sure if this is the right approach. Let's bring up the composer again. Should we save the text along with the embeddings or keep them separate? So it wants to save the embeddings in a separate file because since we already have since they're gonna match, right?
Yeah.
Recommend keeping text separate. Okay, it wants to keep it separate. Fine. So, except, well, you actually wrote this right, but we want to use, now we need to go to OpenAI documentation, OpenAI docs. We go to embeddings, grab the model name. And we want to, for best performance, we want to use large. Okay, let's bring up the composer again, and let's use async OpenAI and get the embeddings in parallel. Let's input the model name so it doesn't confuse it. Am I going too fast? You're getting it?
Yeah, I'm following along. Just do your thing. I'm watching.
You can watch it later as well. Okay, except, okay, I'm just, so I'm gonna trust it. Okay, but let's make sure embeddings not found, creating new embeddings. Otherwise, it load from file. Let's run this. Reviewing code takes way longer than somebody was saying. O1 with reasoning now can, think for 5 seconds and spew out a long breakdown of the question that you were asking, which takes me, he says, 1 hour to read. He says the bottleneck is me. 5 seconds. Okay, see here we save the chunks separately. Sorry, the embeddings. So it's in here. Chunk one. Man, embeddings are so hard to read.
Yeah.
I just wanna. This is not just chunk one, right? Okay, we can test this quickly. Test apply. How many items are in embeddings.json? Let's quickly run this in a split terminal because this one is still running. It's asking us for a query. Let's not bother that.
Okay.
5. Okay, so it has 5. We had 5 chunks. Good. It's good to test. That's a bit of a catch-22. So it wrote all this code for us. What if it had a small bug? I guess if this was a more serious use case, you would really want to kind of review it. Or at least what I do is this, say, like select the code and ask again, like, what does this code do step by step? At least let it explain you the code so you see if it's doing the thing like importance to define constants, embeds chunks, query. Oh man. See how am I write it very shortly. Stores embeddings in file use, loads or creates embeddings, allows users to input queries. Anyway, but you can do this kind of probing to see if it's doing the things you want to. Like such as will it embed each time again and again. No, we won't embed the chunks each time. Code is designed to efficiently embed only once, then you reuse embed. You know what I mean? You can do this kind of probing to see, instead of trying to read it line by line, you can actually use the LLM to tell you if it's doing it or not. Okay. So we did that. I'm going to delete this test.py. So what are we going to query? Chunks with context. Also, how many chunks is this returning? Uh, top and 3. Let's say top 1. Okay. Chunks. Uh, let's say Luigi. Let's search for Luigi Federico. Or he was an Italian. Let's say Italian. Let's just say math. First chunk. Oh, see. Okay. Now, when we print, of course, we're only printing the first 500 characters. Let's print all of it. Let's just search for Italian. Oh, well, here's the thing. We're changing the code, but for it to reflect, we need to run it. So let's run it, make sure it doesn't embed again. Embeddings loaded from file. Good. Italian. Analytical engine. Control F. Italian. Yeah. See, see, you see what happened?
Mhm.
Italian mathematician Luigi Federico, but this is the end of one chunk and beginning of another. Italian mathematician. So it got the first chunk that mentions it. You see,
Yeah.
if you were to say two chunks, and search for Mediterranean mathematician. Let's see if this will work. So we're gonna get two chunks. Oh man. Where did we do it? Yeah, it retrieved both. It's difficult to see. Oh, Mediterranean mathematician. Italian. Yeah, here it is. It's difficult to kind of read. I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects. As a patron, you will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well. Let's say print when, let's do Control L. When printing chunks, print them, save them to a JSON file. When printing chunks, also save it to a JSON file. query results. Okay, let's do that. Anyway, this works, right?
Yep.
Mediterranean mathematician. Query results. Search for Italian. So it brought this up in chunk 2. I mean, it thought this has some Mediterranean in it. Let's ask ChatGPT. Is there anything about Mediterranean in this? Also, I'm making all kinds of spelling. No. Okay, well, it's going to work as good as it's going to work, but this is it. Essentially, we did it. It chunks it, and then it gets context for each, creates chunks with context, then embeds it, and then embed and use, you can use it. What do you think? It did
Not
it pretty
bad. Not
quick.
bad. I don't know if I'll be able to use it in anything yet, but at least I'm learning the concept.
Yeah, or how to put it together, I suppose.
Yeah.
Now, reranker. Let's take a look at the reranker real quick. The goal of a search system is to find the most relevant results quickly and efficiently. Traditionally, BM25, which is used in search engines like Google and stuff, I believe, or more advanced versions of this, being used to rank search results based on keyword matching. Recent methods such as embedding-based cosine simulator have been implemented in many vector databases. These methods are straightforward but can sometimes miss the subtleties of language and, most importantly, interaction between documents and queries intent. As a matter of fact, it did, I guess, miss Mediterranean, right? This is where the reranker shines. The reranker is an advanced AI model that takes the initial set of results from a search, often provided by an embedding token-based search, and reevaluates them to ensure they align more closely with the user's intent. It looks beyond the surface level matching of terms to consider the deeper interaction between the search query and the content of the documents. So apparently this is a re-ranking model. So we can just use Gina AI, but then we're going to introduce an additional API and stuff, right?
Okay.
Instead, we can implement this from scratch. Let's do it. So let's copy this embed and use and rename it for embed and use oh man with rerank. Let's quickly do a let's do it to see how we can do it. Anyway, um, I guess we can use Haiku or GPT-4o Mini for it. I think GPT-4o Mini is more cheaper.
Yeah.
So Control A. We can use Composer here, Control K, Control L. I think Control L is going to be the fastest. Use GPT-4. We're going to say GPT-4 and fix its mistakes. 2, re-rank each top and chunk to see if it is relevant to the user query. We can just do it like this. You can do it every which way, right? You can using JSON mode. Only then return the queries which return true for relevancy. So essentially, we're going to use GPT-4o Mini to look at each chunk and the user query and return true or false if that chunk is relevant to the user query. Yeah. But you could do it by a more deeper analysis and allow it to return like rank, like, multiple points of uh, point like rankings, average them. Okay. We're just going to keep it simple. All right. Also, use async OpenAI to do this in parallel. Re-rank. See, so it's gonna retrieve results and then it's gonna re-rank, and we're only gonna deal with re-ranked results. Apply, accept. Now let's take a look at this part. GPT-4o mini. It actually did this correctly. Everything looks correct. Except respond with a JSON object, creating a Boolean is relevant field and a reason field explaining your decision. Okay. You know what? We could have used Grok for this, which would be super fast, but at the same time, GPT-4o mini is going to be better. But since we're playing around, let's go to Grok. Let me grab the Grok code real quick. Grok, actually, documentation. Yeah, let's copy this code. So we can do it like this. L, Control L. Let's paste this. So let's say in the beginning of the script, give user enumerated options for GPT-4o mini or Grok. You know what? Here for OpenAI, or options for OpenAI or Grok. Yeah, we can use both. It's as easy as that. Yeah, look, because the calls are the same. It's just initialize it differently. Okay, except I'm pretty sure this will work, because if you look at this, see, it's exactly the same. Call is the same. Everything's the same except the initialization. Okay, great. Except let's also pass API key, not os.environment, get env. Okay. You can also say or, like that. Let's also print the print whether chunk is relevant or not. If chunk is relevant. Okay. So now when we run this, everything should remain the same except let's use OpenAI. Embeddings loaded from file, and now we say Mediterranean, and I apparently don't know how to spell Mediterranean. Let's grab it from here. If we still have it. Mediterranean. Mathematician. It says false to all. Why? You just thought that. Yes. Let's add one other thing. Add a command option for --s switch between OpenAI and Grok Reranker. So it's going to add a command. Argparse. No, not with argparse, but with user input. Because argparse is when you're typing a command on the command line, you can add additional commands, but we just want this command to be like when you're entering your user query. Yeah, it's not understanding me very well. You know what? Let's skip this part. It's fine. We just rerun it. Rerun. By the way, let's not, because here is the thing. The Grok's example comes with 8 billion, but we want to use 70 billion probably. Settings, limits. Let's use the latest 70 billion. Rerank. Rerank with GPT-4. How does it know which model though? I don't think this was correct because it initializes the API, but then it still uses rerank with GPT-4. Always. So we need to rerank. Let's just call this rerank. And this needs to take in a model name. Model. Okay. It's going to be GPT-4 on Mini if it's OpenAI or Llama 70 billion versatile, and we're going to change it here. So when we call the rerank function, it's going to default to GPT-4 on Mini, but it's going to look at our choice. If it's OpenAI, it's going to use GPT-4 on Mini, otherwise Llama. I think Grok also allows for JSON mode. Oh, okay. Right. Here is the thing. When you make a when you make a query, you also have to embed the query, get the embeddings for the query. Okay. Uh, and the thing is, because we are initializing the client, see, we have to call the embeddings. And this always has to be OpenAI because Grok doesn't have an embedding model. But because we are asking in the beginning for reranker, it initializes the client separately. And then it now tries to send this embedding to Grok. How to fix this? I guess I could just, this has to be always open. Okay, let's ask it. The embedding client always has to be OpenAI. It's just, it's an issue with the client. Yeah, OpenAI client. So it initializes OpenAI client ahead of time and uses OpenAI client for embedding. Apply. This should work. I hope I was able to explain the problem clearly. because we are asking in the beginning which one you want to use for re-rank, it initializes the client, but then it uses that for the embedding, but now we fixed that. So Grok, Mediterranean mathematician, and it still prints wrong. Okay. From Grok, import async. Async Grok. Because we're making async call. Okay, right. So it's doing that, but nevertheless, it's working. But we are printing re-ranking top chunks with GPT-4. Let's find this in the text. Control F. Re-ranking top chunks with F model. We're not defining the model in a global. Re-ranking top chunks. Let's just say re-ranking top chunks. So this way, when we're using Grok, we don't get confused. Lastly, save the reasoning for each chunk re-rank to JSON as well. Apply, accept. So now, let's try again. Oh, gonna rerun it. You can clear your terminal with CLS if you're on Windows, by the way, just by typing CLS and enter. Let's use OpenAI, Mediterranean mathematician. You see how GPT-4 was slower? Query results here. Is relevant false. This chunk discusses Charles Babbage and his analytical engine, which focuses on computer science, historical developments in computing, rather than information about Mediterranean mathematicians. Yeah, it won't. So I guess it makes sense. Even though it mentions Italian mathematician, it says that it doesn't provide any information about mathematics. So I guess Mediterranean. If you were to ask it like this, Mediterranean mathematician is mentioned in this. Yeah, see, it gave true. Ha. So it gave true to 3 of them this time. So I guess it's depending on how you ask it. And we go to query results, and we look at, this says false. This one says true. And it mentions Italian mathematician. See, it says the chunk mentions Italian mathematician Luigi Federico Manabre. True. This one also mentions Luigi Federico. Isn't that cool?
Yeah.
So we did it. So I guess, depending on how you ask. And we didn't ask anything about Italian. We just said Mediterranean. So let's ask it like this. Okay. Is anyone potentially, is anyone who might eat grape leaves for dinner mentioned? Question mark. No, we pushed it too far. Does not mention grape leaves or anything. Okay, but this is it, right? We did a lot. But the idea is simple. Hope you found it useful, Well, so you have any questions or comments? Otherwise, we'll end it.
When you get around to it, get into some vector database stuff, how we can use that with LLMs. Not right now, but just as a thought.
We just did it. Oh, how to use it with LLM. Well, what we did is a vector database, essentially.
Oh,
So this chunk text and the embeddings that correspond to it is a vector, a very rudimentary vector DB.
okay.
But in this implementation, we are only using, we're only printing the results. If you were to add another call here to send the retrieve chunks to an LLM to get an answer, then we build a RAG system. Let's actually do that real quick. Yeah. Let's do it. Let's do it. I'm thinking, let's do composer. Now we probably don't need these. Embed and use, and we want embed and use with rerank. Let's add a, how should we do it? That will be more complex because,
You can save it for another time.
yeah, let's do that. I mean, essentially, because the thing, but I'll tell you why. Because here we are just like we are opening a search result where we search. But normally when you're chatting with an LLM, you're like writing stuff like tell me more about analytical engine or something, right? Which is not a good search term for, because you know what I mean. So normally you would have to have a step in between where you get a model to get the search query and sorry, get the user query and turn it into a search query, and then perform RAG, and then retrieve chunks, and then put it into model's context along with the original question, such as, tell me about Federico or something. It's just not very advisable to run a direct search query. Let's do a very simple version here. Okay, embed and reuse with rank chat. So let's just do it for this file. So Control L. Uh, so when so let's do this. When user inputs query, let's retrieve the chunks, then call GPT-4o mini again with these chunks. So it can answer the user question with these in mind. No JSON mode, let's say, because since this script has an example of JSON mode, it may try to use it again. Yeah. Answer query. You're a helpful assistant. Use the provided context to answer user question. Yeah, let's apply, except, okay, it's actually as easy as that. I was just kind of making it more complex. So what's going to happen is we're going to do everything exactly the same, right? And we're going to we're going to even perform re-rank, and then we're going to get the top chunks that passes re-rank. After that, we're going to do an answer query, either to actually grok or Okay, that's fine, I guess. We didn't really want to. That's fine. Actually, it gave us an option to use both OpenAI or Grok, which is great, actually. To do this, you're a helpful assistant. Use the provided context to answer user's query. If the context doesn't contain relevant information, say so. So we pass in the relevant chunks as context plus the query. Does that make sense?
Yeah.
So now this is an entire RAG system right now. Just because we build an entire vector DB and RAG. Like, make no mistake about it. It's rough around the edges and it's simple, I suppose. So let's use Grok for speed. Let's say uh, how fast was analytical engine in comparison to modern computers? Question mark. So it's gonna perform, see, re-rank, answer. According to provided context, the analytical engine has been built. It would have been very slow. Luigi Federico reported that Charles Babbage believed his engine could form the product of two numbers, each containing 20 figures in 3 minutes. In comparison, a modern CPU can do the same thing in under a billionth of a second. You see that?
Yeah.
So this is actually, I shouldn't have said rudimentary because this is actually kind of pretty advanced RAG because not only we are performing re-ranking, we are also performing this context-aware retrieval, which is pretty much just cutting-edge research just published by Anthropic. So excellent. Do you see why this is a vector DB? This vector DB implementation is rudimentary now, but do you see why it is?
Yeah. Okay.
A vector DB essentially is a database which associates some text with its embeddings.
Okay.
And we did that by having two files, chunks with text and their embeddings separately, because chunk number one corresponds to this text. It also corresponds to this embedding. When you perform cosine similarity, the query is also converted to an embedding like this, and then some mathematical operation happens between this one and chunk 2, chunk 3, chunk 4, and chunk 5. And then cosine similarity returns a relevancy score, mathematical. See, it returns the similarity number, and then you can sort this from higher to lower. Now you have found the top n most relevant chunks. That's how a vector DB works. The thing is, with ChromaDB or with Pinecone or with FICE or one of these fancier vector DB implementations, they just have a more optimized, I guess, uh, way to do this essentially. Because you can imagine, what if we had 1 million embeddings? This embeddings.json file is going to be huge, and we're not going to be able to do it so quickly. See,
Got it.
but essentially it's the same idea. Like the vector DB literally is as simple as some text and its associated embeddings,
Okay.
and we did that.
Good deal.
Yeah. Well, thanks for being here.
Thank you. I always get some nuggets.
Yeah, appreciate it. It's always funner with someone else, which there were more people next time.
Probably next week, everybody will be back.
Yeah. So, yeah, this is pretty cool. I'm excited. I'll make a separate video, plus upload this if you want to rewatch parts of it or something. But do you have any questions, other questions?
No, I'm good. I'm good. I'm like just getting below overwhelmed right now.
Yeah, if you have any clarifying questions, if you want, I can answer.
Yeah. I'll ask when it's time.
Oh, all right.
All right. Thanks a lot.
Yeah, have a great Sunday. Talk another time.
All righty. Bye-bye.
Bye-bye. I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects. As a patron, you will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well.